Hello everyone, and thank you for joining me for this video, what's coming in Petrosys in version 17.4 and 17.5. My name is Kathy Hockwald and I'm the Strategic Product Manager at Petrosys. Today's presentation is going to run through 4 of the things that are coming in 17.4 and 17.5. There's also a bit of a list at the end of the show with a few more of the highlights in those 2 releases. Today we're going to go through the 4 things that you see on your screen. The first one is mapping without map sheets, or otherwise called dynamic mapping. I'm going to show you a new third-party connection that we're going to bring out in 17.5. It's going to be integration with Doug Insight 3 software. I'll then show you the direct import of third-party CHECKSHOTS to a Petrosys WGF and also to DBMap database, and also point display in 3D viewer, which is great for a variety of data, but especially microseismic data. Okay, the first one is mapping without map sheets. So as many of our existing users will know, in Petrosys, whenever you want to create a map, the first thing that we ask you to do is to create a map sheet. Well, what we're doing with mapping without map sheets is removing the requirement to have a map sheet before you can display data. So we still have the full functionality of Petrosys map sheets, but this new feature just means that you can display data and you can play around with the data in the area of interest, and then when you're happy with that, you can go and create your map sheet afterwards. The next thing I'll show you in my first demo is the connectivity with Doug Insight 3. This functionality is due out in 17.5. Now the first release is going to include 2D seismic and 3D seismic navigation, seismic interpretation, and the ability to grid with fault data. So the first release will have direct display, direct gridding, as well as the ability to write Petrosys grids back to Doug Insight 3. So we're just going to jump into the software now, and I will show you those 2 features. So for those of you not familiar with Petrosys, this is the main menu. Now the first module that we're going to use today is the mapping module. So I'll just jump in there. Now one thing I do want to point out at this point in time is the fact that the software development versions that I'm using in these demonstrations are development versions. Hence, just bear with me a couple of times when things don't quite happen the way you might expect them to happen, or we get some error messages coming up, because these are still under development. Now the first thing that you'll notice here is that I have no map sheet displayed, and you'll see that there is a small message in the middle of our window telling us that we're currently using a dynamic area of interest. Now what that means, if I just go and display some data, so I've just clicked on this icon here, which is the display 2D seismic icon. Now, as I mentioned in my brief introduction, we are also introducing the Doug connectivity. So this bit of the presentation is actually going to do 2 things. It's going to show you dynamic mapping as well as showing you the integration with Doug. So you can see here listed I've got quite a lot of different third-party software vendors I can connect to, but we're going to connect to Doug. And I'm just going to go in here and select my seismic project that has some 2D data. Now when you have this working at your on your desktops, you'll be able to read the CRS from your Doug project. Now in the first instance we'll just display those seismic lines. So I'm just going to display the line with the track line display style, and I'm going to post the line names. I'm just going to go OK. And what you've seen immediately is that I've had no map sheet defined, and I've displayed some data, and it's automatically calculated the area of interest that it needs to display all of that data. And there are the 2D seismic lines coming from Doug. You can see here that I can just click on one of those lines and track the line, and the information comes up at the bottom of my screen. So all of this information is not contained within any Petrosys files, it's all coming directly from your Doug project. If I just modify that layer, I'm now just going to turn on some interpretation data. So we'll just pick up my seismic horizon and we're going to display some 2A time data. We'll just turn on those pieces of data, and we'll colour them with blue. So you can now see that I'm pulling across the 2A time interpretation pics from Doug, And now if I scroll along the line, you can also see the picked time down below. And if we modify that layer one more time, I can just color code those 2A time picks with a ribbon map, just allowing us a visual indication of those 2A time values. Now the next bit of DUG data that I can show you are 3D seismic bin grids. So again, I'm going to select a DUG project, and this time I'm going to select a project that contains 3D data. We're going to display the survey outline and the inlines and the cross lines. And just with the 2D data, I can click on my 3D survey, and as I scroll around I can see the inline and cross lines being read to me. Now in this development version of Petrosys, I can also show you the 3D seismic surface feature. At the moment I can just show you values. So again, just like with the seismic lines, we just select the survey, we've got the horizon, the data type, and we're just going to color code the non-missing Z values with the same gradient as we were using for our 2D seismic. So you can see in this instance, the interpreter has only interpreted about 1/3 of this 3D seismic survey. So here we're seeing all of this information being pulled directly from DUG and displayed on a Petrosys map. Now I'll just drag you back to this concept of dynamic mapping, or mapping without map sheets, and I'll just show you what that means. So you can see here we've got our 2D seismic displayed and our 3D seismic. If I turn off our 2D seismic, you'll see that our area of interest has dynamically changed now to only reflect the area around that 3D survey. If I turn that layer back on, we dynamically change to encompass all of those active layers in our display list. So once you're happy with the data and the area that you're looking at, you might want to create a PDF, or you might want to plot this out to a plotter, and so you want to go back to the full functionality of a Petrosys map sheet. To do that, you just use the right mouse button, you give your map sheet a name, and in this case I'm going to pull the style information from another existing map sheet. And you'll see now the same data is displayed on a Petrosys map sheet, and so if I turn off that 2D seismic, my area of interest does not change. So now I did mention in my introduction that you could also grid directly from Petrosys. I'm just going to jump into the surface modelling module of Petrosys, and I'm going to show you how we can bring this data and just create a grid from it. And that's probably jumped behind. Here it is. Okay, so I'm just going to open a previously saved workflow. I've just got 2 tasks in this workflow. The first one is to take this data that I'm seeing here, my 3D seismic and my 2D seismic, and create a grid from that data. So you can see here I've got 2 input data sources. I'll just jump into the input data and show you that in more detail. So you can see here I've got the first data source, which is just connected to my 2D project, and my 3D, so exactly the same data that I'm seeing on my map. Now in this case I'm going to ask the computer to define the area of interest, so it's just taking those 2D data sets and working out the geometry of the grid, and we're going to compute some contours. So we'll just OK, and we'll just run that task. Now I also mentioned previously that we'll be able to write grids back to back from a Petrosys grid to DUG, and that will be done under File, Export, DUG. So you can see here I've got an example of that, where I'm just taking that grid that we've just created, I would write it back to my 3D project, give it a name and a data type, etc. And you would be able to then write that grid straight back to your DUG project. If we jump back into the mapping module now, you can see that I can immediately display that grid we've just computed, as well as the contours. Okay, we'll shut down the mapping module now. We'll jump back into our PowerPoint, and we'll just move on to the next 2 things that I'd like to show you that are coming in Petrosys. So the next one is the direct import of third-party CHECKSHOTS. So this is coming in 17.4. We will be able to read CHECKSHOTS directly from Kingdom, OpenWorks, Petrel, Paradigm and DBMap or PPDM databases. You'll be able to write the data both to a Petrosys world data file as well as DBMap. Now the great thing about this is when you import that data, all of your formation velocities are automatically calculated. So this is average velocity and interval velocity. And what this means is that depth conversion in Petrosys has got even easier. The last thing I'm going to demonstrate to you today is the point display in 3D Viewer. So microseismic has become very popular recently, and we wanted to give you the ability to view these points, microseismic data points, in Petrosys 3D Viewer. But obviously there's a lot of other data types that are quite useful to show in 3D Viewer as well. So today I'm going to show you displaying some microseismic data from an Excel file. You'll see that you have full control over the posting of point colour, including colouring by an attribute which exists in your Excel file. And you can also change the size of the points based on an attribute as well. So if we just jump back into Petrosys, I'll show you the CHECKSHOTS first off. So to do that, you use the Well Import Wizard, which is from the main menu, Import Wells Import Wizard. Okay, there's a very large selection of third-party data sources that you can import wells from. Today we're going to use a Kingdom project. So we're just going to connect to our Kingdom project. We are going to create a new Petrosys well data file to bring this data into. And you'll see down here that I've specified that the seismic reference datum is 0 meters. So what this means is when it computes my formation velocities, they're all going to be referenced to the seismic reference datum, and that means that they're ready for depth conversion. Now down the bottom here you can see that we're going to bring in the well headers, the formation tops, directional surveys and CHECKSHOT surveys. Now this Kingdom project actually has a lot of wells in it, so I'm just going to restrict the selection of wells using a well selection file. So these are the wells that I'm bringing in. And also with the formations, I'm just going to restrict that as well, just to 5 formations. Now this is a new file, but if this wasn't a new file, or you were writing to existing data in a DBMap database, you can select the type of merging that you want to apply. The new part of this panel is the CHECKSHOT survey option down here. Right, so I'll just press the import button. And there we go, we can close that down. Now I'm going to show you this data in a Petrosys world data file, but remembering this data can also go into a DBMap database. Now as I mentioned before, the great thing about this is that it's going to automatically calculate your average and your interval velocities for all wells that contain CHECKSHOTS and for wells that contain formation velocities. Just bear with us here. As I said, this is a development version of Petrosys, and the WDF file has actually is currently undergoing a lot of enhancements, which actually will make it much faster. Okay, so this is the well data file. See, I've got my wells down here. Now if I just click on this icon up here, this is my CHECKSHOT survey icon, and you can see here is the raw data. So what we've done is we've connected to Kingdom and we've pulled in the raw depths and times. Now ideally this should be from a tied CHECKSHOT survey, and then it's gone and calculated all the relevant data for this particular survey. And you can also view this data in plot form. But the really good part about this is if I go into this default spreadsheet called zone velocities, I'll actually see that for all of my formations, all of my velocities have now been computed from using those CHECKSHOT surveys. So in this particular Kingdom project there were no base depth, so I don't actually have any interval velocities, but you can see here that we have the average velocities down to the top of all these formations, and these velocities are referenced to the seismic reference datum, so they're all ready for depth conversion. And these values are visible, you can see them in mapping, and you can also connect them directly in the Petrosys surface modelling module grid these up, and you've got your velocity surfaces ready for depth conversion. Now the last thing I'd like to show you today is the point display in 3D Viewer. Okay, I've made a 3DM file already showing you some point data around a well. So there's our well with our numerous paths. And here you can see I've displayed two different sets of point data around this well. And you can see here that the colours are different, but also the sizes of these points are different. And this size can reflect any attribute that you like. So just to show you how to do this, I'll just go display point data. Now you can display point data from a variety of sources, and the one we're going to do today is Excel. So I've already selected the microseismic Excel file. Just double click on it again to show you. The next thing you need to do is to define a format. If you already have a format, you can use a format file. Just to show you, however, so it doesn't matter about having different or numerous sheets in your Excel file. You can pick up data from any sheet. Now you can see here that Petrosys has already automatically picked up the header of these columns and mapped it correctly. So my eastings, my northings, and my Z depth value. So all I need to do is press OK. You have the option of scaling the Z values, changing the symbol type, colouring. You could colour by an attribute. So we might choose to colour by magnitude, and you've got the full range of Petrosys colour gradients if you wanted to use those. However, today we'll just colour by, we'll just make everything blue. We will, however, scale the size of those point data by an existing attribute in our Excel file. And in this case it's going to be magnitude, and we'll just boost that up by a scale of 5. And now you can see that we have yet another set of point data being shown around the wellbore. Okay, we'll close that down and we'll jump back into the presentation just to finish off. Now, as I said, there are a lot of new features coming in Petrosys, and I can't show them all to you today. Some of the things are support for 64-bit. You will not have noticed, but the first part of the demonstration was running using Petrosys 64-bit software. This won't be noticeable to a lot of you, but for people that are using large 3D surveys in other applications such as Petrel, you will be able to read those surveys in Petrosys now. Some other things are reading of Esri LYR files, stacking velocities from seg-y, ZMAP polyline reading, and lots of improvements around gradients. Some saving of formulas in surface modelling, grid processes arithmetic, bubble maps, and a new spatial editor tool. So for many of you that will be familiar with Petrosys CFP, or the Contour Fault Polygon Editor, it's been completely rewritten, and it's going to be much, much better. It's also going to include the ability to edit surfaces interactively in mapping, improvements in 3D Viewer, and also some cross plots. So I'd like to thank you for attending today, and please don't hesitate at any point if you have some ideas of what functionality you'd like to see in Petrosys, please get in touch with us. Thank you.